My name is Ilsha Wirsati, and I would like to present you a paper titled Combining Convolutional Neural Network and Long Short-Term Memory to Classify Synapses. And I am the first author in this paper. The second author is Professor Zuherman Rustam. The third author is Valerie Virginia Putri Wibowo, and we are from Department of Mathematics, University of Indonesia. The talk is divided into 4 parts. I'll start with introduction, methods, result, and conclusion. Now, introduction. Sinusitis is a common health problem because of an inflammation of the mucous membranes lining one or more paranasal sinuses. Unhealthy sinuses are filled with fluid, bacteria, or viruses. You can see in the picture. Sinus is a small cavity that is connected through the airways called ostia. There are 4 locations of sinus, as you see in the picture. There are frontal sinus, on the back of the forehead bone, sphenoid, ethmoid, and maxillary, inside the cheekbone structure. Actually, there are 5 types of sinusitis, but in this paper, we focus on chronic and acute sinusitis. Acute sinusitis infection lasting less than 4 weeks, while chronic sinusitis infection lasting more than 12 weeks. And for acute sinusitis, there are 2 common causes, such as bacteria or viruses. And in most cases, unresolved acute sinusitis can cause chronic sinusitis. In the early stage, sinusitis inflammation can mimic a common cold. Then around 90% of patients with colds have an element of viral sinusitis. Also, chronic sinusitis and acute sinusitis have similar signs and symptoms. To help medical staff classify sinusitis precisely, the detection tool must be improved. Now we move on to the method. Recently, over the classic machine learning methods, deep learning has demonstrated indisputable superiority. In this research, the authors combine convolutional neural network with long short-term memory to take the advantage of both methods. Convolutional neural network is good to extract the feature, while long short-term memory can connect the previous information to the present task. And I'm going to explain convolutional neural network, or CNN. CNN has 3 types of layer: convolutional layer, pooling layer, and multi-layer perceptron. First, and the main layer is convolutional layer. Convolutional layer is used to transform input into a form that is easier to process by going through filter or kernel of a fixed size without losing essential features. The convolution of kernel and input can be written as follows. K is kernel filter with length m, and x is input vector with length n. Next is pooling layer. This layer is used to reduce dimension. There are 2 common approaches. The pooling operation is called max pooling if it uses the maximum value. If it uses average value, then pooling operation called average pooling. And the last one is multi-layer perceptron. Basically, it is neural network that is used for classification tasks. For the activation functions, the authors choose rectified linear unit and ADAM as an optimizer. In this paper, we use one-dimensional convolutional neural network because of its advantages, such as computational complexity is lower than 2-dimensional convolutional neural network, and it requires shallow architecture. Therefore, when CNN can use a regular hardware for training and low-cost applications. The next one is long short-term memory, or LSTM. LSTM is advanced types of recurrent neural network which can remember and connect previous information to data obtained in the present. LSTM is using a combination of activation functions to choose what information to remember or forget, so that only important information is remembered. In LSTM architecture, there are 4 gates. 1 is forget gate, 2 is input gate, 3 is update gate, and the last one is output gate. And the main key that makes LSTM can remember long-term memory is the presence of the city or cell state. The first one is forget gate. This gate decides whether the information is thrown away from cell state or not. And then input gate. This gate decides which value will be updated. And the next one is update gate. This gate updates the old cell with value from input gate. And the last one is output gate. Output gate decides which value is to be output from the layer. This is the illustration of LSTM. The first one is forget gate. Information from the previous hidden state and information from the current input is passed through the sigmoid function. The closer to 0 means to forget, and the closer to 1 means to keep. To update the cell state, we have the input gate. First, we pass the previous hidden state and the current input into a sigmoid function. This gate decides which values will be updated by transforming the values to be between 0 and 1. 0 means not important and 1 means important. Now we have enough information to calculate the cell state. This gate updates the cell state to new values that the neural network finds relevant. Then calculate it with this formula to get new cell state. And the last one is the output gate. The output gate decides what the next hidden state should be. First, we paste the previous hidden state and the current input into a sigmoid function. Then we paste the newly modified cell state to the tangent hyperbolic function. The output is the hidden state. The new cell state and the new hidden is then carried over to the next time step. And now, combination of CNN and LSTM. This is the example from Wang 2016. To measure the performance of proposed method, the authors use confusion matrix. And formula can be written as follows. And then, this is the results. In this paper, the authors use dataset CT scan of sinusitis patients from Cipto Mangunkusumo Hospital, Jakarta, Indonesia. Sinusitis data consists of 200 data, where 98 patients are chronic and 102 patients are acute sinusitis. We can see in the table, there are 4 features, such as gender, males represented by 1 and females represented by 2. Hounsfield or density of the tissue, air cavity, and diagnosis. 0 is defined for acute sinusitis and 1 is defined for chronic sinusitis. This research used 7% data for training and hyperparameters. Kernel size is 2, dropout is 0.1, batch size is 50, epoch is 100, and optimizer is Adam. Now for 1D CNN method. The accuracy of testing data reached 97.5%, while on data training reached 98.12%. Then error on data testing is 0.0249. Error on data testing reached 0.018. You can see in the picture. And the next one is the proposed method, 1D CNN LSTM. The accuracy of data testing reached 98.33%, which is higher than 1D CNN. On data training, 1D CNN LSTM has 99.28% of accuracy. For the number of error on data testing is 0.016. Error on data training is 0.0071. Finally, we arrive to the conclusion. The result is 1D CNN LSTM has 98.33% accuracy on data testing, which is higher than 1D CNN with 97.5% accuracy. Therefore, a combination of CNN and LSTM is more recommended to use than CNN itself for this case. The authors believe that future research can modify or develop this method to give good accuracy in the medical field or others. And that's all for me. Thank you for your attention.